We turn now to the subject of conditional convergence and alternating series. Let's start with the definition. We're going to say that a series, sum of an, converges conditionally if the sum of an converges but does not converge absolutely. So to put that in more concrete terms, we're going to say is the sum of an converges conditionally if the sum of an converges, in other words, the sum of regular an converges, but the sum of its corresponding positive term series diverges. So just to be clear, conditionally converge is a statement that we make about a particular series, which is really making a statement about two different series. It's saying that the series itself converges, but its corresponding positive term series diverges. So in other words, the series does not converge absolutely. So um, in order to see what this means, let's just recall for a minute the absolute convergence test. Recall that if the sum of the sum of the positive term series an converges, then the regular series converges. So in other words, if a series converges absolutely, then it converges. We can now chart the possibilities of convergence and divergence between these two series, the positive term series and the regular series. So I've put them down here. Let's make them a little bigger. There we go. So I've written at the top of this chart, I've written the two possible series, the positive term and the regular series. So this is how we would describe them. We'd say that if both of them converge, then the series converges absolutely. That's true because we know that if the series converges absolutely, then it also has to converge. So we know that if there's a converge in the left column, then there has to be a converge in the right column. If the positive term series diverges but the regular series converges, this is when we say the series converges conditionally. And if they both diverge, then we just say that they diverge. The fourth possibility I've saved for last, and that is where the series converges, where the positive term series converges and the regular series diverges. I've represented that by this unicorn because there is no such animal. That's just not a possible combination. A previous class of mine observed, by the way, that this unicorn appears to be wearing a sweatshirt. I'm not sure why that is. When I first saw this picture, I thought that was just some sort of horse collar that had been adapted for unicorn use. But looking at it more closely, it does in fact appear the unicorn is wearing a sweatshirt. That has no significance to the notion of conditional convergence, just an observation. We come now to the topic of alternating series. So to define an alternating series, let's suppose that an is a positive sequence. So in other words, all the terms in the sequence an are positive. If we make the terms flip back and forth between positive and negative, in specifically that pattern, positive, negative, or negative, positive, then we refer to the resulting series as an alternating series. So I've put two examples of alternating series that you can form from the positive sequence an. And we're going to assume, by the way, that the sequence starts with n equals 1, but of course we could start at any place. There's no real significance to whether it starts at 1. So in one example, we start with an, with a positive an, and then we multiply positive a1, and then we multiply a2 by negative 1. So it's a1 minus a2 plus a3 minus a4, with that pattern continuing to repeat. The normal way that we would write that in sigma notation is we'd write sigma from n equals 1 to infinity. We'd put this alternating term that we first encountered at the beginning of sequences, negative 1 to the n. I've written n plus 1 here because I want to start at 1, and n plus 1 plus 1 is 2, so that's negative 1 squared. That gives us, that ensures that the first term is going to be positive. The other option is we write it the way that you see here, where I just put negative 1 to the n starting at n equals 1. That would make the first term negative. It doesn't matter which term is positive first or negative first. In both cases, the series is an alternating series. I've put up some examples of alternating series. We need to start, of course, the positive sequence. So I've put up three positive sequences. We have here an equals n. That's just the sequence 1, 2, 3, 4, 5, etc. I have bn equals 1. That's the constant sequence 1, 1, 1, 1, 1, going on forever. And then for Cn, I've put a geometric sequence 1 over 2 to the n. So that's going to be like 1 half, 1 fourth, 1 eighth, 1 16th, etc. So the following series are examples of alternating series, where I just make the terms alternate back and forth, positive and negative. So the first one is 1 minus 2 plus 3 minus 4 plus 5. And I've written it in sigma notation this way that you can see this is the alternating term. And since I want it to be aligned in such a way that the first term is positive rather than negative, I make this negative 1 to the n plus 1. Here in number 2, I formed just a different sequence, sorry, different series using an. Here I want to start with 8. Since 8 is an even number, if I want the first term to come out positive, I actually have to use negative 1 to the n instead of negative 1 to the n plus 1. So just be aware that you have to choose this negative 1. You have to choose whether this is going to be negative 1 to the n or negative 1 to the n plus 1 a bit carefully, but this gives us a different alternating series. Here I have, since bn equals 1, if I put this alternating term in front of it in number 3, that just becomes negative 1 or 1 times either 1. So that becomes negative 1 plus 1 minus 1 plus 1 minus 1. And finally, done the same thing with the geometric series. So this is just alternating again, positive, negative, multiplied by the term in the sequence. And this, by the way, this is how you write. I'll just highlight one of them. This is how you would write an alternating how you'd write an alternating series. You can also, of course, write you can write the term you can write the general term in line. In other words, I could have written it this way as just negative 1 to the n plus 1, 1 over 2n, like that. Or I could have combined them. I could even have put this negative 1 inside those parentheses, and I would have had to adjust this n plus 1. But there are different ways you can write these, but this is sort of a typical way that you would write the series, like this.